Good morning. Today we're going to go through some basic exponent manipulation and some multiplying of polynomials. Some of this may be review, some of this may be a little new, but we're going to take you through each of these step by step and try and get you going with some math this year. So we're going to multiply each of the following monomials. Monomial just meaning one term, single term. Now, if we go back to our earlier years in algebra and we talk about our different properties, I am able to take this term and I am able to switch the order of these terms, and those two expressions are equivalent. And the reason I'm able to do that is because multiplication is a commutative property, meaning I can flip the order and it's not going to matter. Okay, so if I did it that way, that might make a little bit more sense if I'm taking a look at multiplying these guys, because those are like terms, and multiplying these guys, because those are like terms. Okay, so if I multiplied 3 times 10, I would get 30. And if I multiplied x squared times x to the fourth, anytime you are multiplying variables, you want to think add exponents. Okay, so multiplying variables, you want to think add exponents. So if I'm multiplying x squared times x to the fourth, I want to think 2 plus 4. So if I did my 2 plus 4, that's going to get me 6. So now I have x to the 6th. And that would be our final answer. Okay, same idea over here. If it's easier to rewrite it and write your numbers right next to each other, then let's do so. If not, and you can see how this problem is working, you don't have to do this step. All right, we'll try one more this way. So I have a negative 2 times a negative 9. So negative times negative is positive. 2 times 9 is 18. And then again, I'm multiplying variables, so I want to think add exponents. Keep in mind, this variable has an exponent of 1, even though it's not written there. So if I'm going to be thinking adding my exponents, I'm going to have a grand total of 6 here. So I have 18x to the 6th. Okay, down here. Now I have x and y's. So I want to keep variables with variables, numbers with numbers, x's with x's, y's with y's. Okay, so if I were to rewrite this again, right, so we said we can move the terms right next to each other. So I have x, I'm going to put another x right next to it, and I'm going to take my y's, and I'm going to put my y's next to each other. So that, hopefully, will tell you. Okay, we're going to multiply those together, x's with x's, y's with y's. Okay, so 4 times 8, 32. Same principle. When you multiply variables, you add exponents, but remember, it's just of the common terms. So the x's are common. So if I added 5 and 2, I get 7. For my y's, the y's are common. Keep in mind, even though it's not written, there's a 1 there. So 1 plus 3 gets me y to the 4th. Okay. And then for this last one, I would expand this. That's just me. That way there, we're not making any mistakes right now. When we get into this a little bit more, maybe we don't have to expand it. But that's what that looks like. Okay, so numbers with numbers, 5 times 5, I get 25. Letters with letters. When I multiply variables, I add my exponents, so I think 4 plus 4 gets me 8. Okay, trying this next part. So it says fill in the missing portion of each product to make the equation an identity. Best way I can explain an identity is I want to think to myself an equivalent expression. So when I'm making an identity, I want these things to be equal. Okay, so this is almost doing what we just did up above, but backwards. Different way to think of it. So I know my final answer should be 18x to the 6th. I have one term, I have to find the other term. Okay, so if we did what we did before, I'm saying to myself, all right, well, 3 times something has to equal 18. Okay, well, if I had to figure out what that was, I could divide each side by 3 and solve for that. And if I divided, I would find, well, that something would be 6. Okay, we're going to do the same thing with the x's. So I'm thinking x squared times something should get me x to the 6th. And now we just have to think, when I'm multiplying variables, I want to think add exponents. So I know that this has to be an x, and I want to think, what would that exponent have to be? So 2 plus what would get me 6, and that would have to be a 4. So I would have x to the 4th. Okay, now you can always go back through and distribute this through and check, does this 3x squared times 6x to the 4th, when multiplied, does that equal 18x to the 6th? And it does. Okay. Same thing on letter B, but again, now we have x's and we have y's and we have constants. So we just do it part at a time. Okay, so I'd start with my constant and I would say 8 times what is going to get me 40, and that what would turn out to be 5. 8 times 5 gets me 40. Okay, if I start with the x's, start on this side. So I have x times something is going to equal x squared. So again, I have to think, what would the exponent be? This is x to the 1st. So x to the 1st, x to the, I have to think, what am I going to add? That should be another 1 in order to get 2. So I have x to the 1st. Okay, my last term, I'm going to start here with y squared. So I have y squared times something has to get me y to the 7th. Okay, so that's something. Again, I know that this has to be a y, and I have to think add. So 2 plus 5 would get me y to the 7th. So now I have y to the 5th. Okay. Letter C is about the same thing. The one thing we just have to worry about when we get to y is that's going to look a little different. Okay, so we start again. So 15 times something equals 90. And again, if we're not sure, I can do 90 divided by 15, and that would solve, and that would tell me 6. Okay, for the x's, I have x times something gets me x to the 4th. So again, I have to think, well, it's got to be an x, but what's the exponent? Keep in mind that's a 1, so 1 plus 3 gives me 4. And now with the y's, again, I'm starting here, so I have y times something equals y. Okay, well, I just want y back, so I have to think y times what number would get me y? Well, y times 1. Anything times 1 will always produce the same value. So with that being said, I don't need anything here. That 1, I don't have to write 1s, right? Like we don't have to write a 1 up here. I don't have to write a 1 for my exponent. I don't have to write a 1 there. Y is already there. All right. Going on to the distributive property. So our distributive property, we've done this a lot, and we just have to be careful when we distribute, watch your signs. That's the biggest thing. So as we're distributing here, I don't have to worry too much about signs because everything's positive. Keep in mind I'm multiplying the 4x by both terms. So 4x times 5x. Okay, when we multiply variables, we need to add exponents. So 1 plus 1 gets me 2. And I have 4x times 2. All right, so just like we did up above. So 4 times 2 gets me 8. There's no x over here, so it would treat it like a 1, kind of like what we had in our last problem. So x times 1 gets me x. That's your final answer. Okay, we go to letter B. So for letter B, same idea. Now we have negatives we have to watch out for. So I'm going to distribute through. So I have a negative times a positive. I know that's a negative. 5 times 10 gets me 50. And I don't have an x value here, but that's treated like a 1, so x times 1 gets me x. Okay, move to my next term. Now I do have a negative, so negative times a negative, that makes it a positive. I do have a constant here. I shouldn't say I don't. It is there. Again, that's just a 1, right? So we have 5 times 1 gets me 5. X times x gets x squared. The variables, add your exponents. Okay, same thing down here. We're going to distribute all the way through, and every term is going to get this. So 6x times x squared, 6x cubed. Watch your signs. 6 times a negative 4, so we got to think that's a negative 24. X times x, x squared. And our signs here, positives, right? So 6 times 8 gets you 48, and that would be x. Now our last one, we just have to be careful because we have y's. We have a bunch of terms, okay? We just have to make sure, again, x's with x's, y's with y's, constants with constants. So if I multiply this one for my first term, 8 times 1 gets 8. Goes to the x's. X squared times x cubed, we add those exponents, x to the 5th. And there would be like a 1 here for the y, so I just have y squared. Go to your next term. 8 times a negative 2 is a negative 16. X squared times x squared is x to the 4th. Y squared times y, add your exponents, how about y cubed? Go to your next term. 8 times 5 is 40. X squared times x is x cubed. Y squared times y squared gets you y to the 4th. And your last term. 8 times a negative, there's a 1 there, so that's a negative 8. X squared, keep in mind, there's really no x's, I can treat it like a 1, that's an x squared. Now I have y squared times y cubed, that's going to get you y to the 5th. Okay. Go to our next page. And this is very much like what we had just done on the previous page. So you're filling in the missing part of each product in order to make that equation into an identity. So very similar to what we did to number 2. Okay. What I'm going to do on this part is I'm going to give you the answers and I'm going to have you try these on your own and see, can you get the same answers that I got? And if not, this is a perfect time to circle it and come on into class tomorrow and bring your questions. Okay, so check these answers, try these few problems on your own. And again, watch your signs. That's going to be the biggest difference here. Okay, and if you need any help with those, let me know. Okay, moving on. So we're going to multiply the following binomials. Binomial just means 2 terms. So this is a binomial, this is a binomial. And we're going to express each product as an equivalent trinomial. A trinomial actually would be like this down here in number 6. There's 3 terms. So this is a binomial, this is a trinomial in number 6. Okay, and it says you can use an area model to help find your product if necessary. I'll show you what the area model is on A, I'll show you a different method on B, and then we'll try some other ones. Okay, so your area model, some of you may be familiar with this. That's where you're going to create a box. And I would take perhaps this first term and I would write this on the top. So x would go here, 5 would go here. And then I would write this on the side, x and 8. And now what I would do is I would work my way through systematically and I would multiply. X times x is going to get you x squared. X times 5 is going to get you 5x. Go to the 8 and do the same thing. 8 times x gets you 8x. 8 times 5 gets you 40. And then anything on a diagonal, which is really only these 2, you're going to add because those are like terms. So to get your final answer, we're going to have x squared. Now I'm going to add 5x plus 8x and get 13x. And then to that, I also have a positive 40. So that's one method. Some people like that because that works if you're doing binomials, trinomials. It doesn't matter. That will always work for you. Okay. A different method is the FOIL method. FOIL, meaning first, outside, inside, and then last. All right, so let me show you what I mean here. So here's my first term. So 3x times 2x, I'm going to have 6x. Let me go to the outside. My outside terms would be 3x and a negative 7. So I have a negative 21x. Now I go to my inside terms. So positive 2 times positive 2x, that gets me a positive 4x. And then I go to my last 2 terms. 2 times a negative 7 is a negative 14. So just like we did on the other ones, we have to combine like terms. Right? So I have, ooh, and you know what? I made a mistake. That should be 6x squared, not bad. So we have 6x squared And then if I combine a negative 21 and a positive 4, I'm going to have a negative 17x minus 14. Here is my final answer. Okay. Same thing with letter C. It looks difficult because you have squareds. I'll be honest with you, it works exactly the same way. So what I'm going to do with letter C and letter D is the same thing that I did in number 4. I'm going to provide you the answer. I'd like you to try these. So I have x to the 4th plus 6x minus 40 for an answer for letter C. You can try either the area method or the FOIL method, see which one you like. Okay, and for letter D, your answer I have here is 10x squared, 10x to the 6th plus 13x cubed plus 4. Okay, you can try those, see what you think. Okay, we're going to try a couple more on number 6. The only difference is, like we said in the beginning, we have, instead of 2 binomials being multiplied together on 6a, I have a binomial and a trinomial. Okay, so if you're doing this, you could do the area method, that box method that we did. Now you would just have a box that has 2 by 3. That's an option. You can still do that distribution method. That's kind of one that I'm used to. So I'll show you this. If you need help with that area method, let me know. Okay, so I'm going to start here, and I'm going to just take my first term and multiply it to each of the terms in that second factor. So I have 2x times 4x squared, so 2 times 4 gets me 8. X times x squared, we have x cubed. 2x times 5x, I get a positive 10x squared. 2x times negative 7, so again, watch your signs, I have a negative 14x. Now we go back through and we do the same thing for the negative 3. Negative 3 goes to each of these terms. Okay, so negative 3 times a positive 4x squared is a negative 12x squared. Negative 3 times 5x, I get a negative 15x. And a negative 3 times a negative 7 is a positive 21. Okay, and to simplify, we want to combine our terms that are the same. So these two terms are the same because they're both x squared. These are the same because they're both x's. Okay, I don't have any other cubed, so I have 8x cubed. Go to my squareds, a positive 10x squared, a negative 12x squared. I have a negative 2x squared. Go to my x's, I have a negative 14x and a negative 15x for a total of a negative 29x. And then I just have my constant of plus 21. It's always a good idea, good habit to get into to box your final answer in, just so I know where your work has ended. Okay. Letter B, notice what we have here. We have something that says it's cubed. Okay, so kind of like we did on the front page when we had a term that was squared, cubed just means we have 3 of these. So 2x plus 5 times 2x plus 5 times 2x plus 5. And for now, I would say expand it. For now, I would also say, let's work with our first 2 terms. So I'm only worrying about those guys. Don't forget about this one. We'll come back to him. But we're going to either do that FOIL or that area method here. So we're going to start again. 2x times 2x, I have 4x squared. 2x times 5, I have a total of 10x. Now we're going to work on the inside. 5 times 2x, I have another 10x. And then my last one is 5 times 5. I have 25. Okay, so again, we're going to combine our like terms. So that's going to give me a total of 20x plus 25. Now keep in mind, we have this other factor. So I have to bring that down. Okay, and we're going to do the same thing that we did up above. I personally like to start from the left and go into the right. It doesn't matter as long as you're consistent. So I'm going to distribute this way. And then when I'm done with that, I'm going to do the same thing with my second term. Okay. So 4x squared times 2x, I get a total of 8x cubed. 4x squared times 5, I have a total of 20x squared. Okay, now I'm going to work inside. Okay, so we have these 2 terms. These are next. Okay, so I have 20x times 2x, that's a total of 40x squared. Now I have 20x times 5, that's a total of 100x x. Okay, so now we have our last term. So I have 25 times 2x, there's 50x. And I have 25 times 5, and that gets you a total of 125. Okay, last thing that we need to do again is combine our like terms. So I have my squareds, x to the first. So final answer here, 8x cubed plus 60 x squared plus 150x plus 125. Final answer, box it in. Okay. We are going to go to our last question. This is a little bit more of a thought question. So it says, think about the expressions. Okay, for what values of x will this expression be equal to 0? All right, so if I want this to be equal to 0, I'm going to force this guy to be equal to 0, because right now it's just an expression. Difference between an expression and an equation. An equation, you have an equal sign. This is an expression. But I want this to be equal to 0, so I'm going to set it equal to 0. So I have to think, when I have two numbers, that's what this is. This is a number, this is a number. Okay, so number here, number here. When I have two numbers and they are being multiplied and I know their answer is 0, I have to think, well, how would I make a number 0? Okay, any number times 0 would give me 0. So that means x minus 8 could be 0. Or that means x plus 4 could be 0. If I know that that has to multiply together to equal 0, at least one of those has to be 0. Okay, so if I were to solve this, I'm going to add 8 to each side, and I'm going to have x equals 8. And if I were to solve this, I'm going to subtract over and find x is going to equal negative 4. So what values of x would make this expression equal to 0? It would either be x equals 8, so I can say over here, either x equals 8 or x equals negative 4. Either one of those answers would make that expression equal to 0. So now it's saying write this product as an equivalent trinomial. So again, that means 3 terms. All that means is expand that out. So if we have our terms here, we have our expression here. All we're going to do is, again, either that FOIL method, that box method. So I have x times x, we get x squared. I'm going to go to my outside terms. I'm going to go to my inside terms. And then I'm going to go to my last, which is negative 32. Okay, again, combine your terms. X squared minus 4x minus 32 is our expression. This is an equivalent trinomial to this. Those are 2 binomials, that's 1 trinomial. And now it's saying, show that this trinomial also equals 0 at the larger value of x from part A. Well, our larger value of x was 8. Okay, so I have to show that this, x squared minus 4x minus 32, also equals 0 when x is 8. In other words, plug in 8 and simplify. Okay, so I have 8 squared minus 4 times 8 minus 32. So 8 squared is 64. 4 times 8 is 32 minus 32. Orders of operations, I would just go from left to right in this case. So 64 minus 32 is 32. Minus 32 is 0. So we've just shown that that trinomial is also equal to 0. Okay, I hope this was a good review. Get us starting. We'll practice some more in class. And again, come to class with any questions that you have. All right, hope you guys have a great day.